Hey guys, here we are again for some more rational functions. I'm hoping to get through 2 examples with you on this video so that you can see the other types that will get you through all 9 of your problems. So refresh our memory for the r, that's our roots. So we're going to take the numerator, set it equal to 0. Since there's no variable up there, we are going to have none, meaning it's not going to cross the x-axis, or it's not going to touch the x-axis. Our a, remember, our a is where we set the denominator equal to 0. Notice if I take x minus 2 squared, which means x minus 2 times x minus 2, and set that equal to 0, I don't actually have to do both of them. You only really need to do one. And when I solve, x is equal to 2, which means I'm going to have a vertical asymptote. Our a stands for vertical asymptote. We're going to have it at 2. So we're going to go to positive 2, decide where we want that to be, and label it. X is equal to 2. Up and down. Now, I picked this one specifically because it does have tangency, because notice in the denominator you have a perfect square, meaning if I multiply those out, that'd be a perfect square trinomial. So we have tangency, so we're going to say we are tangent at, and it's wherever this is equal to 0, which that's equal to 0 at x is equal to 2. So what I'm going to do is I'm going to come over here and I'm going to put a T and circle it to remind me when I get ready to do my graphing. When I see that, then I know that my 2 tails around this asymptote should go in the same direction. Okay? Now our end behavior, remember, is our Bobo Botan eats our C. Bobo Botan eats our C. Remember, we're talking about our root, our degrees. So the degree of our numerator is 0. There is no variable. So we have no exponent. The degree of our denominator is 2. So notice it's bigger on the bottom. So that's Bobo. Big on bottom, y is equal to 0. So we're going to draw our horizontal asymptote at y equals 0. And I just draw it right along the top so that we can see it and extend it out to the sides of your y-axis. So that would be y is equal to 0. And then lastly, we do our y-intercept. Y equals, and I plug a 0 in everywhere I see an x. 0 minus 2 squared. Well, 0 minus 2 is 2. Sorry, 0 minus 2 is negative 2. When I square negative 2, negative 2 squared is 4. So 5 over 4 is a little bit bigger than 1, but all we really need to know is that that's the coordinate 0, 5 over 4. Because remember, our graph is just a sketch. So we're going to go along our 0, positive 5 over 4. It's going to be, we can say here. And there's no values on there, so it doesn't really matter. Put it to where we can see it, and then label it 0, 5 over 4. So then we know that that's what that coordinate is. And then when we get ready to graph it, again, remember these look like a fence. And so think about our dog and how his path is running. Here's our dog. If he's going to go to the left, he's going to be on top of the graph. So it goes along the side because it's an asymptote. If he were to go to the right, he's going to run into the fence. So he's going to go this direction. Now our T reminds us it's together, which means instead of jumping on the other side down here to be in this yard, we're just going to jump straight across the fence. And he has another dog over here running along this fence. And that's what our graph would look like. Okay? So I want to skip on your notes page all the way, whoop, not that far, to, how far did I go? Oh, there we go. I want you to look at number 6, just because it looks like it's got a lot of interesting things that are going on. All the others that you look at, they're either going to have some togetherness or they're going to have the asymptotes are going to be moved around. But 6, notice we have something new because we've got this polynomial down on the bottom. Okay? So we're still going to do the same things. R for root, numerator equal to 0. We don't have any variables, so we know that it's none. That doesn't happen often, but when it does happen, it's okay. Don't freak out. It's going to be all right. A for asymptote, or our vertical asymptote, that's where we're going to set the denominator equal to 0. So when I have x squared plus 2x minus 3, and I set that equal to 0, we know that we need to factor x and x equals 0. Factors of 3 that will give me 2 would be 3 and 1. To get a positive 2, I need a plus 3 and a minus 1. Now you see why we did a lot of that factoring earlier, right? If I set each of those equal to 0, I know that x is equal to negative 3. If I set minus 1 equal to 0, I know that x is equal to positive 1. Now don't write them just with a comma, write them separately, because remember, that is two separate equations, which means two separate lines. So we're going to draw a line at negative 3. X equals negative 3. And don't forget the bottom part. And then we're also going to draw one at 1. So you kind of want them to look a little bit to scale, but they do not have to be perfect. That's not what we're looking for. It's the idea, the concept of that you have everything where it needs to be. Okay? Now remember, the one we just did, tangency, we had tangency, but this one we don't, because notice when we factored this, it was not a perfect square. So there is none. We want to say none so that we know that we did that one. We can check it off our list. We don't think that we just skipped over it. Okay? Our in behavior, remember in behavior comes from the degrees. The degree of the top, just like on the last one, is 0. The degree on the bottom, and actually just like the last one, is also 2. It's big on bottom, and big on bottom, Bobo, means y is equal to 0. Big on bottom is 0. That's what our Bobo helps us remember. So we know that we have an equation y equals 0 we want to graph. So it goes right here along our x-axis, and that's y equals 0. And then our y-intercept, just like every single time, we're going to plug 0 in for every x that we see. 0 squared plus 2 times 0 minus 3. Well, this is just 0. This is 0. So in the denominator, I just have a negative 3. So negative 2 over negative 3 is really just 2/3. So our coordinate is 0, 2/3. Always write it as a coordinate so that you don't forget. The whole reason why you did that y-intercept was to get a point. So 2/3 is going to live about here. That's just where I picked for it to be. So label it 0 and 2/3 so that you can see where it is. And then think about our dog. Our dog's ready to run. Here's where my dog is. If he were to go to the right, we have a corner right here, which means our fence pushes him to go up this way. If he were to go to the left, he's going to go this way. And then it's like, okay, well, I don't have any dog anymore. But remember, we have an asymptote here. We don't have any togetherness, so we know when we go on the other side of the fence, it has to be opposite. So it's not going to be going the same direction, and then he just follows the fence line there. Same thing when we go over the negative 3. He's going to go to the left side, but not going up because there's no togetherness. It's going to go down, and then he'll go around this way. Okay, so that's what your graph will look like. Basically, your graph is your answer. That's the work that you need to have done. So practice some of these. Most of them have one or two, at least an asymptote of each, a vertical and a horizontal. And then you'll have some that may have 2, like this one did. You may have some togetherness. You may not have togetherness, and that's okay. So if you have any questions, jump on our Hangouts. Remember, Mr. Cleveland is at 9 o'clock. I'm at 11 o'clock. Miss Blatt is at 1 o'clock, and Mr. Monbrun is at 2 o'clock. And then I'll be back on again at 7 if you still have questions in the evening. So hopefully you're able to keep up with your stuff. Hopefully you're doing fine, you're still doing all your social distancing, taking care of yourself, taking care of your family, whatever you need. If you need anything, make sure you reach out and let us know what we can do to help. All right? So y'all have a great day.